So now we turn our attention to percentage by mass. So this is essentially just calculating percentages of how much of a certain substance or how much of a certain element there is in a compound. So let's have a look at how we do it. So essentially, if we want to find the percentage by mass, what we need to do is, and this is of a particular element in a compound, we need to consider the total relative mass of this element in the substance, so in the compound, divided by the relative mass of the compound, and we want to, because it's a percentage, times that by 100. Okay, and this should always be a value between 0 and 100 because it's a percentage, okay, and it's the percentage composition of something, the percentage that something is making up something. So we're looking first of all at potassium in this substance, potassium cyanide. So the formula is KCN. We're told that in the question. There's only one atom of potassium in there, the K. So that means in my equation, we're going to have on the top just the total relative mass of potassium, which is 39, because there's only one atom of potassium. We're going to be dividing that by the relative mass of the compound. So we've got one atom of potassium, so that's 39. We've got one atom of carbon, so that's 12 from up here. And we've got one atom of nitrogen, so we're adding 14. And we're going to times whatever number we get there by 100. So that is equal to 39 divided by 65 multiplied by 100. And that gets us a neat answer of 60%. So if you got that, give yourself a mark. We move on to B. And this time we're looking at bromine in calcium bromide. So we've got CaBr2. So I'm going to write that out here. Now, remember, the equation is the total relative mass of the element that you're looking at in this compound. So we're looking at bromine, and you'll notice that in bromine there are two atoms of, in calcium bromide there are two atoms of the bromine. Okay, so that means we need to do 80 plus 80 because there are two of these atoms. I'm going to divide this by the relative formula mass of calcium bromide. So we've got one atom of calcium, 40, and then I've got my two atoms of bromine. I'm going to times that by 100 because it is a percentage, so we end up with 160, and we're dividing that by 200, and if we do that calculation and multiply it by 100, we get an answer of 80%. Now there's 2 marks available for this one. You get 1 mark for calculating that 160 on the top, and you get another mark for getting 80%. Now, part C, we're looking at hydrogen in beryllium hydroxide. So once again, I'm going to write that a little bit bigger. We're going to write out the formula of BE brackets OH close brackets 2. So we want to find out how much hydrogen is in there by mass, and first of all we need to deduce how many atoms of hydrogen there are. Well, we've got 1, but it is in the brackets, so remember what that actually means is we've got not just one hydroxide ion, but we've got 2. So there's 2 atoms of hydrogen in there. So our percentage by mass is going to be equal to 1 plus 1 divided by the total relative mass of beryllium hydroxide. So beryllium has a relative atomic mass of 9. There's only 1 atom of beryllium. Then we've got 2 lots of 16 because we've got 2 oxygen atoms. And then we've got our 2 hydrogens as well. Okay. We've got to times it by 100 because it's a percentage. Now if we evaluate what's there, 1 plus 1 is 2 divided by 43 on the bottom of this equation multiplied by 100, And we get an answer of, if you do that correctly, 4.65%. 2 marks once again. You get 1 mark if you got 43 on the bottom. You get another mark if you got 4.65 as your final answer. If you got 4.7, that would be perfectly acceptable as well. Finally then, we've got D. We're looking at the percentage by mass of oxygen in gallium nitrate. So it's a bit more of a complicated substance here. So here is our formula. Now, first of all, we need to figure out how many oxygen atoms we've got in this compound. So we've got the 1 gallium, but then we've got 3 lots of nitrate. So NO3, NO3, NO3. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 lots of oxygen in the gallium nitrate. So on the top of my equation, we're going to have 9 times 16. And then on the bottom, we're going to have the total relative formula mass. So we've got gallium, which has a relative atomic mass of 70. There's only 1 atom of that. We've got 3 atoms of nitrogen. So that's going to be 3 lots of 14. And then we've got our 9 atoms of oxygen. So that's going to be 9 lots of 16. It's a percentage, so we need to times it by 100. This gives us, if we do this calculation, 144 divided by 256, and we're multiplying that number by 100, and you get a final answer of 56.25%. Once again, this is worth 2 marks. You get a mark if you got the 256 on the bottom, and you get a mark if you got 56.25 or 56.3% as your final answer. So essentially, if you know how to do percentages, you'll be able to calculate the percentage by mass of an element in a particular compound.